All right, ladies and gentlemen, so in front of you, you've got this image, and we're basically going to be pulling kind of everything together. We're going to pull together last unit and the things that you know from last unit with what I just taught you with the mole-to-mole ratio. And then technically, you'll have everything you need to solve all of the stoichiometry problems, and it just comes down to some problem solving then, okay? So first, let's start with some of the things that we know. We know from last unit that 1 mole is equal to the molar mass. So you know how to convert from moles to mass, or if you're given mass of a material, you know how to convert from mass to moles. So we learned that. So I'm going to fill this in on this paper as I'm going and talking about it. And so this first piece is just what we know about how to go from moles to mass. Next thing we learned how to calculate moles for gases. And we learned that when it comes to a gas, there are 22.4 liters in 1 mole of a gas. And then finally, we also learned the number of atoms or the number of molecules in a mole. And so there are 6.02 times 10 to the 23rd atoms or molecules within 1 mole. So at this point, I filled in everything on the left side of this image here. We can be given moles of a material and find mass or liters or atoms. We could be given the mass or liters or atoms of a material, and we can figure out how many moles that is. Well, the last couple of days, we've learned about what's called the mole-to-mole ratio. And the mole-to-mole ratio is going to allow us to go from one material to a different material. And the only way to do that is to have a balanced chemical equation. And so we've been practicing that. We've got a balanced chemical reaction. If I have 2 moles of one material, how many moles of the other material do I need? If I've got 4 moles of one, and how much of the other one do I need? So we've been practicing that for a couple of days. And that's kind of our connecting piece for stoichiometry, because we're going to be given an amount of one ingredient, and we're going to have to find out an amount of a different ingredient. And again, the only way to get from one ingredient to the other ingredient is to use that mole-to-mole ratio. And so we've got this big map right here. When we filled in the whole left side, if we make the connection then to the right side to have a different material, and then we just do the same pieces. Once I get to a different material, I know 1 mole is equal to the molar mass is equal to 1 mole. I know that 1 mole is equal to 6.02 atoms, 6.02 atoms to 1 mole. I know 1 mole is equal to 22.4 liters, 22.4 liters is equal to 1 mole. And that's it. We've put it all together now. And so what we can actually do is, if we're given, let's say, grams of one material, we can then find out how many moles we have. We can find out how many moles of a different material in the balanced chemical reaction we would need, and we can figure out how many grams that would be, or we can figure out how many atoms that would be, or we can figure out how many liters that would be. And that's it. So let's look at a first practice problem together. So the first step is we are going to need a balanced chemical reaction. It says nitrogen gas reacts with hydrogen gas to produce NH3. Write a balanced reaction. That first part, pretty easy. We know nitrogen is a diatomic molecule. We know hydrogen is a diatomic molecule, and we're going to produce NH3. And then we need to balance it. And balancing this one is pretty easy. We just need a 3 in front of the hydrogen and a 2 in front of the NH3, and we're good to go. So that's where we're going to start with this problem. So up at the top of the paper, I kind of took our big road map and I kind of just threw it in there so we can kind of see it. You can see over on my left-hand side, I've got, okay, mass, atoms, liters. We know how to get from those to moles. And then we use our mole-to-mole ratio to go from moles of one material to moles of another material. And then we can then get to mass of that other material, or atoms of that other material, or liters of that other material, still just using our basics from our first unit. So this question says, how many grams of nitrogen are needed? So we have to start with the nitrogen. And well, we want to figure out how much nitrogen. And we have 6 times 10 to the 23rd atoms of NH3. So if I look at this problem, I'm starting with atoms. So I'm going to start all the way over on the left side at atoms. And I've got atoms of NH3. And I have to get to grams of a different material. So first step, I have to go from atoms of the NH3 to moles. We use Avogadro's number. 6.02 times 10 to the 23rd is 1 mole. If we do that math, we have about 1 mole of NH3. Next step, to get from NH3 to nitrogen, we use our mole-to-mole ratio. So I'm going to use my balanced equation to figure out how many moles of nitrogen I'm going to need. So I've got 2 moles of NH3 for every 1 mole of nitrogen. That's what the balanced equation tells me. Now, I know how many moles of nitrogen, but I now need to figure out how many grams that would be. And the only way to figure out grams of a material is to use the molar mass. So I'm going to calculate my molar mass of NH3, and then I'm going to take those moles of NH3 that I have, and I'm going to use the molar mass, and I'm going to calculate of nitrogen. I want to know my grams of nitrogen. I'm going to use my molar mass of nitrogen, and I'm going to calculate how many grams of nitrogen I'm going to need. All right, let's try another one. The next one says how many grams of NH3, so we're going to be working with this guy, will be produced if you use 55 grams of hydrogen gas. So we're going to be working with this guy. So again, if we kind of think about this, we're going to start with 55 grams of hydrogen gas. We're going to have to find out how many moles of hydrogen gas do we have. Then we can use our mole-to-mole ratio to figure out how many moles of NH3, and then finally we can calculate our grams of NH3. So I'm going to start with my 55 grams of hydrogen gas, and we need to find out how many moles that would be. So 1 mole of hydrogen gas is going to weigh 2.02 grams. What that does is that tells us our moles of hydrogen. Once we've got our moles of hydrogen, we can then use our mole-to-mole ratio. We don't want hydrogen anymore. So 3 moles of hydrogen, we want to find out how much NH3. So that step is going to get us to our moles of NH3. And once we're there, we can then use the molar mass of NH3 to figure out how many grams of NH3 that would be. So I do 55 divided by 2.02. I get 27.22 moles of hydrogen. So now I can figure out, well, I don't want hydrogen anymore. I want to find out my NH3 moles. So I'm going to do 27.22 times 2. Divide that by 3, and so that's going to be 18.15 moles of NH3. So I now know that basically I've gone from 55 grams of hydrogen, and I figured out, well, how many moles of NH3 do I need? If I've got 55 grams of hydrogen, that means I've got 27.22 moles of hydrogen. Well, if I have that much hydrogen, I use my mole-to-mole ratio here. That means that's the number of moles of NH3 that I would need to make this reaction be occurring with my 55 grams of hydrogen. So I've got my 18.15 moles of NH3, and I need to know how many grams that'll be, because that's what I'm asking for. It's asking more how many grams. Well, I know that 1 mole of NH3 is approximately 17.04 grams. So I'm going to do 18.15 times that molar mass, and I would be making 309.28 grams of NH3. So I started here with grams of hydrogen, and I figured out how many grams of product I would make. And that, ladies and gentlemen, is stoichiometry for you.